In the vast expanse of our galaxy, a place filled with frozen gas giants, barren rocky planets, and seemingly endless silence, there exists one world that defies expectations. K2-18b. Orbiting a cool red dwarf star more than 110 light-years away in the constellation Leo, this distant planet has become the focus of intense scientific scrutiny, and for good reason. K2-18b might be the closest analog to Earth we have ever discovered, a planet that may harbor life beyond our solar system. For years, astronomers noticed peculiar signals from this remote world. Initial observations hinted at the presence of water vapor in its atmosphere. Subsequent studies detected traces of carbon-based molecules. But the most groundbreaking revelations came from the James Webb Space Telescope, which recently conducted an unprecedented atmospheric analysis of K2-18b, revealing clues that go far beyond simple chemistry. The data streaming back from James Webb has shaken the scientific community. For the first time, we have clear biosignatures, chemical markers that, on Earth, are produced exclusively by living organisms. This evidence marks a shift from speculation to observation. It signals a moment in human history when we may finally accept that life exists beyond our home planet. K2-18b is classified as a Hycean world, a hybrid between a water world and a planet with a thick, hydrogen-rich atmosphere. It is roughly 2.6 times the radius of Earth and nearly 9 times as massive. Despite its size, K2-18b occupies the habitable zone of its star, the region where temperatures could allow liquid water to exist on its surface. This makes it one of the most promising candidates for hosting life. Unlike the dry, rocky landscapes of Mars or the turbulent, gas-dominated environments of Jupiter, K2-18b appears to be covered by a global ocean, protected by a dense hydrogen atmosphere. This thick atmosphere moderates temperature swings and shields the surface from harmful radiation, creating conditions that could support biological processes. James Webb spectroscopic analysis confirmed the presence of water vapor, carbon dioxide, and methane, 3 essential ingredients for organic chemistry and life as we know it. But the real surprise came with the detection of dimethyl sulfide, or DMS. On Earth, DMS is almost exclusively produced by marine phytoplankton, tiny microorganisms that play a critical role in our planet's carbon and sulfur cycles. The presence of DMS on K2-18b is a significant discovery. It suggests that similar biological activity could be taking place beneath the planet's ocean surface. Alongside DMS, the telescope also detected dimethyl disulfide, DMDS, a more complex molecule linked to microbial life in Earth's oceans. Together, these chemicals form a compelling case for the existence of microscopic alien life on K2-18b. Scientists like astrophysicist Niku Madhu-Sudan have emphasized the weight of this evidence. These molecular signatures are not random artifacts, they are statistically significant and consistent with biological processes. This marks the first time we may be observing the atmospheric footprints of life beyond Earth. But what form might that life take? If DMS is truly being produced biologically, the simplest explanation is that K2-18b's oceans harbor phytoplankton-like organisms, tiny, floating microbes that harness the faint red light from their cool star through a form of photosynthesis adapted to their environment. Some researchers speculate that K2-18b could also support more complex life. Perhaps filter-feeding creatures drift through nutrient-rich waters, absorbing organic compounds and leaving chemical traces behind. Others imagine alien analogues to flying fish, organisms adapted to the planet's low gravity and dense atmosphere, capable of short bursts of movement through the ocean or even the lower atmosphere. In essence, K2-18b might resemble Earth not as it is today, but as it was billions of years ago, when life was just beginning to flourish in the planet's primordial oceans. And just as Earth's early biosphere gradually transformed its atmosphere, we may be witnessing a similar evolutionary process unfolding on this distant world. This discovery has sparked a new debate within the scientific community. If K2-18b truly hosts life, should humanity attempt to communicate? Some experts argue against it. Physicist Mark Buchanan warns that actively sending messages could expose Earth to unknown risks or disrupt a fragile alien ecosystem. Ethical philosopher Dr. Anthony Milligan stresses the importance of caution, highlighting our moral responsibility to protect extraterrestrial life forms from contamination or harm. Others take a more optimistic view. Avi Loeb, for example, suggests that any intelligent species capable of detecting our signals likely already knows we exist, and may not view us as a significant presence. Regardless, communication attempts face an immense challenge. A message from Earth would take over 110 years to reach K2-18B, with another 110 years required for any reply. For now, our role remains one of observation. Meanwhile, space agencies and private ventures around the world are quietly adjusting their plans. Although current propulsion technology would take centuries to send a probe to K2-18B, projects are underway to develop next-generation telescopes capable of continuous, detailed monitoring. NASA's LUVOIR and HABEX missions, the European Space Agency's initiatives, and China's CNSA are all preparing to advance the search for habitable exoplanets. On the frontier of propulsion, the Breakthrough Starshot initiative proposes launching miniature probes propelled by lasers at up to 20% of the speed of light, potentially reaching K2-18B in about 500 years. While this timescale far exceeds a human lifetime, it represents a remarkable leap in our ability to explore neighboring star systems. The cultural and philosophical implications of this discovery are profound. Religious leaders, philosophers, and scientists alike have weighed in, interpreting what life beyond Earth means for humanity. Some view it as evidence that life is a universal phenomenon, part of a grand cosmic design. Others express apprehension, concerned about the impact such revelations could have on societal worldviews. On social media, excitement and curiosity abound. Hashtags like #K2-18BeLive and #OceanWorld trend worldwide as documentaries and creative projects spring up, capturing the public imagination. Governments, while cautious, balance enthusiasm with rigorous scientific assessment. At the same time, discussions around planetary protection have intensified. If K2-18B harbors life, it is imperative that humanity respects its evolutionary journey. Astrobiologists like Dr. Monica Vidari advocate for establishing exobiological sanctuaries, designated protected zones around exoplanets showing signs of life, where exploration is limited to remote observation to avoid contamination. International panels are debating guidelines to create interstellar no-fly zones and restrict emissions from future missions. These precautionary measures reflect a growing awareness that discovery must be tempered with responsibility. Because even microbial life, no matter how small or silent, represents a precious thread in the universe's vast web. K2-18B challenges us to reflect not just on alien life but on our own planet and our place in the cosmos. It offers a window into Earth's distant past, showing how fragile conditions must align for life to thrive. Studying this ocean world could teach us invaluable lessons about biological origins, planetary evolution, and the preservation of our biosphere. In many ways, K2-18B is a mirror, reflecting what Earth was billions of years ago and hinting at what life might become elsewhere. It transforms our perspective from isolation to connection, from doubt to hopeful anticipation. No longer just a distant point of light in the night sky, K2-18B has become a symbol of possibility. It reminds us that the universe is alive with potential, that we are part of a grander story still unfolding. So, we leave you with this question. Do you believe K2-18B is home to life? Should humanity reach out and attempt contact, or remain cautious observers? If this marks the first confirmation that we are not alone, what will be the next chapter in our shared cosmic journey? Share your thoughts in the comments below. If this story inspired you, subscribe to Discovery at 2.0, enable notifications, and share this video with others who gaze at the stars and wonder. Because in the vastness of space, moments like this remind us that the universe may be vast, but it also feels a little smaller and much more alive.